Okay, I was wrong. This is another quadratic inequality. And what's going to happen on this one is it's not going to be factorable, so we're going to have to use a quadratic formula. So I just wanted to show you how that works out. So again, I want to have 3x squared on the right because, yeah, there we go, sorry. I wanted the 3x squared on the right because it's a positive leading coefficient. So I'm moving the other two terms to the right-hand side. So I'm subtracting the 2x from both sides and the 4 from both sides. Okay, so again, I want to find the endpoints first, and I'll do that by solving the associated equation, because that's what the quadratic formula works for, equations. And so I'm going to get x equals something, right? So that's x equals the opposite of b, which is the opposite of -2, which is 2, plus or minus b squared. Since it's squared, you could just write 4, because it's -2 times -2. But I'm just showing you what I'm doing in case you're not too comfortable with the quadratic formula yet. Then minus 4, and that 4 is always there. That's not the 4 from above. That's just the standard 4. Times a times c. A is 3, and c is -4. That's where the 4 from above went. And then it's going to be over 2, always a 2, times the a, which is 3. Okay. And then I just simplified it a little bit. You can factor the 4 out of the two terms inside the square root, and then bring them outside the square root as a 2, and then cancel the 2's outside if you want. You should get square root of 13. Right? Like that. Now you could factor the 2 out of the numerator and then cancel it with the 2. Or if you understand that well enough, you could just cancel the 2's. As long as there's a 2 in both terms in the numerator, right? Anyway, those two 2's cancel there. And so you get 1 plus or minus square root of 13 over 3, whatever that is. It's two different numbers. So I just approximate them so I can put them on a number line. But then when I actually give the answer, usually I would give the exact answer. Your homework and exams, they might actually ask you to estimate it. But if they do, they'd have to tell you how many places. Remember, if they don't tell you how many places to estimate it to, you need to use the exact value, which is the thing with the square root. Okay, so I'm just doing this so I can find test points, right? So it looks like 0 is a good test point in between the two. -1 would be a good test point, and 2 would be a good test point. So that's probably what I used. Yeah, -1, 0, and 2. So I try each of those in the equation. It's not factored, but that's okay. I can just plug the numbers in and calculate, right? So I want that to be negative. Because the test points, it won't be equal. Only the endpoints will it be equal. Notice the endpoints were solid because it's 0 is greater than or equal to, right? Okay, got to try the test points. X is -1. I'm just plugging it in to see if I get a negative number. I actually have to compute this. 5 minus 4 is 1. It's not negative. What about 0? 0 is pretty easy. -4 less than 0. Yep. What about 2? You got 12 minus 4 minus 4. Or 12 minus 8. That's positive. I wanted it to be negative, so no. So now I can fill in the region that works, which is just the one in between. So when I write my interval, if they ask me to estimate to 2 decimal places, I would just have parenthesis minus 0.87 comma 1.54. kind of makes me very nervous as a mathematician because there's endpoints, and the endpoint is not negative 0.87. That's not the endpoint. It's actually further to the left of that. So it leaves out points, which I don't like. So I would end up probably using the square root. So I'd have the one on the left is the 1 minus square root of 13 over 3. And the one on the right is 1 plus square root of 13 over 3. So I think I wrote my answer that way. Right? Remember that if you ended up getting integers out of this when you did this stuff, then the original, or even rational numbers, the original was factorable. You probably should have done it that way. But anyway, that's my answer for that one. So now the next one we'll do rational inequalities, but just very basic ones. They don't do really complicated ones at this point.